Hello everyone, and welcome to the After Hours. This is the Effector series episode 3. In this episode we're going to refactor our code a little bit, add the ability to both increment and decrement the counter, ability to do so by arbitrary amounts, let the counter start with a predefined value, and we will also add some tests. You can follow along in the blog post or check out the episode 3 tag in the repository, which I'll link down in the description. Let's get started. So first, we're going to do a little bit of a cleanup. We should get rid of some of the code that the original template has created for us, just to make it a little bit nicer for ourselves. So as much as we like the logos, they all have to go. We love you, Vít, but we have another star of the show, which is Effector. So let's do that. We no longer need the old hook-based code, so that is gone. We can get rid of the hook. We can get rid of the notice. Now our component is very barren. We can get rid of the imports as well. So now the code is very, very clean. And we can proceed with what we've set out to do. Yeah, we want to also do some cleanups on a model file. I usually like to have my factory names capitalized and my instances to start with lowercase, just to kind of tell apart what's the blueprint and what's the actual item. So let's go to our model file and make those changes there. After we do this, we will have to fix up some of our imports. And we have to fix up our invocations as well. And, the rest, if we've done everything correctly, should still remain the same and should still work, which it does. Excellent. So there's one thing that we're doing in our application file, which we'd rather do in our model file, and that is just exporting the type of our factory and what it produces to the world. So let's just add that here. We're going to call it counter model, and the type of that model will be the return type of the factory itself. Yep, that looks good. Now we can also import that type in our application file. And with that in mind, we can fix up the declaration for our counter component. So right now we're kind of leveraging this type from before, so we can get rid of this and we can replace it with our counter modal type, which everything should work. But I also like to use the function component type from React. I don't know, I've heard various things about it, but I kind of like using it. To me, it makes things a little bit clearer. So here's what we're gonna do. Okay, with this in mind, again, our functionality is still good. All right, so we've got rid of stuff. We reduced the noise, and now we can focus on additional functionality. So for starters, let's make the counter start from an arbitrary value, since sometimes we might not want to start with a 0. Let's go to our model file and make the following changes. We are going to export another type, which is going to signify our settings. And in this type, we will just expose our initial value. And because we don't always want to provide it, we might declare it as optional, and we set its type to be number. And now we simply have to pass these to our factory as parameters. Factory can only take one positional argument. So if you need to pass multiple things to a factory, you should just wrap it in an object and pass that object. So this is what we're going to do. And so after passing our settings, when we initialize our store, instead of initializing it from 0, we can initialize it from initial value. And in case it wasn't provided, we can just default it to 0 in our method definition. With that in mind, again, everything still works as intended, but now we should be able to set up our factory to start with some arbitrary number. So let's do that. When we're doing the invocation, we're going to keep the first one as is. Now we just have to provide it an empty object so that it's doing the right thing. And then for the second one, we can say initial value, we can set it to be 10. And now if we refresh our page, we shall see that the first counter is starting with 0 because that's the default, and the second counter is starting with 10. And if we press on a button, you know, it keeps incrementing, both of them do. All right, perfect. With this out the way, just incrementing seems a little bit minimalistic, so let's add the ability to decrement our counter as well. There's a couple of different ways that we can do that, but you know, we're just gonna follow the same pattern that we've already been following. And for that, we will create another event. And we will effectively wire up the sample the same way. We can also get rid of this code because it's not really relevant to what we're doing. So we're going to grab our sample code and we're going to replace it with decrement. And in here, we obviously want to be decrementing. And now we just don't need to not forget to export it from our factory. Well, not export it, but return it, but you get what I mean. Now, we can bring in the decrement into our counter component, and we can reshuffle the card content a little bit just to kind of make it a little bit nicer. So we'll get rid of this. Oops. Okay, let's just start it from scratch. So we're going to have a button. On click, we are going to call the decrement function because it's going to be to the left of our value. We signify it with the minus sign, and then we're just going to display the counter value. And after that, we can leverage this and we can increment and, you know, use the plus instead. Okay, it's not very happy. Sometimes Vite can be a bit difficult, but you know, we just restarted and hey, so now we have our counter with the negative and positive. So now we can move in either direction, which is pretty neat. Okay, so now that we have this, we've made all of the changes, we refactored it. Let us add the ability to increment or decrement by an arbitrary amount, because, you know, if you want to increment it by 100, clicking 100 times is not ideal. And even though it's a contrived example, you know, we can do that. So what is happening here? We're creating our events. And if we look at the type of our event, it says it's an event callable of void. And that basically signifies that there are no arguments to be passed to that event. But if we wanted to, we could. And let's say if we want to increment it by an arbitrary number, we can just create an event that takes a number. So now our types are basically saying that it's an event callable of number, which means that when we call it, so this code is not going to be happy because now it's expecting an argument but got none. So we'll fix that in a bit. First, we have to wire it up. Okay, so now our event can take a payload of a number. But how do we access that payload? Well, here's where sample comes in. In a sample, if we're using both clock and source, we can have access to both values in our FN and also in filter, but we haven't even touched filter yet, so we're gonna deal with that a little bit later, maybe in the next episode. But yeah, if you supply source and clock, then the first argument to fn is going to have the value of your source, and the second argument, which we haven't used until yet, will use our value for our event. And because right now both types are the same, we see current and increment are both numbers. Sorry, I'm dealing with decrement here. So we're going to use minus, and we're going to decrement it here. And we have to do the same procedure for our increment. Okay, so now that we've done this, I mean, our code for our modal is still happy. However, our code for our invocation is not so happy because it expects arguments that we're not yet providing to it. So in our original fashion, we can just provide it increment by 1 and decrement by 1, and we can verify that it indeed is doing the right thing. But now, we can create more buttons, and let's say if we wanted to decrement it by 5, and maybe we can increment it by 5 as well. We are effectively using the same event, which is giving it a different payload. And now, as you may observe, we can increment by 1 and 5, and we can decrement by 1 and 5. So that is somewhat fancy. Now we have all this functionality, and we can increment and decrement 5 times faster. So now let's do some tests, because we started to write more business logic. We kind of want to have some tests to make sure that everything is doing what it's supposed to be doing, and we also get to see a little sliver of the magic of Effector's tests. But we have to do some prep. For this, we will install vtest. And we also need to wire it up to our package.json file so we can just invoke it in a standard npm run test fashion. So let's come back here. And under our scripts section, we will add, with this in mind, if I run npm run test, it will complain because we obviously don't have any tests yet. So let's create some tests. Okay, so modal.test.ts. And let's start creating our tests. I'm gonna put down a bunch of imports first, just because, it'll save us some time later, but I'll try to explain what all of these are for. Okay. So we're importing some usual suspects before each describe expect test. You've seen it. We are importing our subject, which is the counter factory. And then there's a couple of other new players that have entered the arena, namely fork and all settled. And as I'll write a couple of tests, I'm going to give you a little bit more information about what they actually do. So let's make sure that our world starts in the correct state by writing some initialization tests. I'm going to grab some code that I've written off screen and paste it here for the sake of timing. And here's what we're doing. Okay, we're writing a test saying counter without initial value is initialized to 0. And then another test that says counter with initial value is initialized to that value. So we just want to make sure that everything in our world behaves as it should at the very start of it. So now if we run our tests, both tests pass, no surprise there. So let's take a look at what's happening here. We have our test subject, which we obtain by invoking our factory and passing it no parameters. So it should initialize with the default state of being 0 for the counter. And here comes a little magical piece that is super cool. And like this one thing is basically, some people say that this one method is totally justifies migrating your business logic to Effector. So what is fork? Fork is a very cool method. Essentially, it makes a copy of the world. It forks the world. And it can also do additional things, like you can substitute the value of store, and you can substitute your methods for your effects. So, wouldn't it be nice in real world if you can say fork the world, and in the values you say my bank balance is $1 billion, and a handler for buy a car will return you a Bentley or a Maybach or something. That'd be kind of neat, but maybe not so great. But anyway, a guy can dream. Okay, so when we create this fork of the world, we haven't really done anything to this world, and we want to observe it. So now when we get the state of the counter from our subject, in that world, we expect it to be 0. And, because our tests pass, we can certainly say that it was. And then in the second test, we're basically doing the same thing, only we're passing the initial value. And after observing the state of the world, it is in fact 10. So, all is good in the world. So this tests our code in terms of, having it initialized correctly. But now we also like to verify that the functionality of incrementing works correctly. So again, I'm going to bring in some code that I wrote off screen. And in this code, we're going to be testing the incrementing behavior. And, so for each test, we're just going to have our subject. But here's that second function, all settled. Here's that function comes into play. And basically, we have our brand new world, which we forked. So the scope signifies, that copy. And all settled is a magical function. You poke the first domino for your computation, and all those dominoes start falling. Your computation graph is executing, which includes all asynchronous effects, side effects, all of that stuff. And it's smart enough to know when all is settled. No work needs to be done for that particular computation, and we can now observe the state of the world. And we poke that first domino by calling the increment event, and we're calling it on our scope. So we're calling it not on just our main world, but we're calling it on that forked world, and we're passing it a parameter. So we're expecting our state after this to be equal to 1. And, I just copy pasted it, and V has rerun it. So now we have 4 tests that are passing. So again, everything is good in the world. Let me just resize this a little bit so we can see that all of these tests work. In the similar fashion, apologies, I will get some code for the decrement, which essentially mimics the increment code, but this is mostly for completeness sake, just to make sure that, we have all of our ducks in a row. And once this runs, now we have 6 tests passing, and we can tell the decrement is working, and it basically works exactly the same way. We set the decrement, or rather, we poke that domino for decrement, and right now it's only 1 domino. When it falls, our computation is complete, but further along in the series, we're going to have more complex computation graphs with side effects, with temporal side effects that take some time. They are asynchronous, and all settle can handle all of that absolutely no problem. Okay, now that we've done all these things, I'm about ready to wrap this up, but I kind of wanted to show you a little bit where we can, we have multiple counters, and wouldn't it be nice if we could just get the value of all of them by, deriving some stores from existing stores. So I'm just going to go back to our app file, and I'm going to create another store, which is going to be a derived store, and I'm going to call it counter total. And I'm going to leverage the combine method from Effector, which, if we look at its definition, it takes some number of stores and returns a derived store. And there's an overload that allows us to, perform computations on all of those stores. So we're just going to plug them in. So we're getting the counter from counter 1. We're getting the counter from counter 2. And now we can have a function that basically is going to sum them up together. And if we look at the parameter types, again, it's going to be number and number because our first store contains a number and the second store contains a number. So our final component is a store of number. And we can use our regular primitives like use unit to display it on screen. So let's do that. Let's create another component called total. And it's going to be a function component that doesn't take any props. And this component will simply pull the total value using useUnit and render it on screen. So now we just need to chuck it into our main component. Yeah, that works too. And if we look at our page, we should be able to see that it works harmoniously in congress between the two counters and combines the total. And if you have the React DevTools installed and you have the refresh, or rather redraw enabled, you can see that only the relevant components are re-rendering during this computation, and you haven't had a use memo or anything of that sort. So this is about where we're going to wrap up today. In the next episode of this series, we'll start exploring more aspects of Effector. Make sure you check out the blog post, which should contain everything from this video pretty much verbatim. Get the code from GitHub repository and leave a comment if you have any questions that you'd like answered. I will see you in the next one, and I hope you have a great rest of your day. Goodbye.